آج سافٹ ویئر کوالٹی ایشورنس کا 16th لیکچر ہے. پچھلے لیکچر میں ہم نے سافٹ ویئر انسپیکشنس کو انٹروڈیوس کیا تھا اور ایک بڑا اسٹرانگ کیس پیش کیا تھا کہ سافٹ ویئر انسپیکشنس جو ہیں وہ بڑی افیکٹو ہیں ان ڈیفیکٹ ریموول ان دا سافٹ ویئر انجینئرنگ ایکٹیویٹیز. بہت سارے آپ کو پبلش ڈیٹا سے بھی میں نے دکھایا تھا کہ جو افیکٹونیس ہے آف سافٹ ویئر انسپیکشنز وہ بڑی ایک اسٹیبلشڈ ہے. اس کے علاوہ اس کے بعض اینسلری بینیفٹس بھی ہیں، مثلاً امپلائی مورائل اچھا ہوتا ہے، کسٹمر سیٹسفیکشن بہتر طور پر آپ اچیو کر سکتے ہیں، شارٹر ٹائم ٹو مارکیٹ ہے پروڈکٹس کے لیے. اسی طرح لانگ ٹرم فائنینشیل اسٹرینتھ آف دی آرگنائزیشن از آلسو این ویری امپورٹنٹ اینسلری بینیفٹ آف یوزنگ سافٹ ویئر انسپیکشنز ایز اے ڈیفیکٹ ریموول میکینزم اور ڈیفیکٹ ریموول ٹیکنیک. آج بھی ہم اینسلری بینیفٹس کے اوپر بات کریں گے. آج ہم کنٹینیو کریں گے اپنی ڈسکشن سافٹ ویئر انسپیکشنز کے اوپر. لاسٹ لیکچر ہم نے اینڈ کیا تھا کہ وہ پری کنڈیشنز کیا ہیں جو کہ سافٹ ویئر انسپیکشنز کے لیے ضروری ہیں. آج ہم ڈسکشن شروع کریں گے ان سکسیس فیکٹرز کی جو کہ انسپیکشن کنڈکٹ کرنے کے لیے کمپنیز نے فائدہ مند پائی ہیں. مثلاً وہ فیکٹرز جو کہ پبلشڈ ہیں کہ یہ اگر ہم یوز کریں یا ان فیکٹرز کو امپورٹنس دیں تو انسپیکشنز جو ہیں وہ زیادہ کامیاب رہی ہیں یا زیادہ بہتر طور پر ڈیفیکٹ ریموول کے کام آ سکی ہیں. پہلا سکسیس فیکٹر جو ہے وہ یہ ہے کہ وی ہیو دی کمپنیز کیپٹ ٹو دا بیسکس. بہت زیادہ فرلز انہوں نے ایڈ نہیں کی بلکہ جو بیسک انسپیکشن پروسیس ہے جو کہ ہم بعد میں ڈسکس کریں گے اس کو انہوں نے فالو کیا. سو کیپٹ دا بیسکس، ویری سمپل فارمولا ہے یہ سافٹ ویئر انجینئرنگ کے اندر بھی. جب بھی آپ کسی نئی ایکٹیویٹی کو شروع کرتے ہیں تو یاد رکھیں یو آلویز ہیو ٹو کیپ تھنگس ویری سمپل ان دا بگننگ، اس کو بعد میں پھر آپ الیبوریٹ کر سکتے ہیں. سیکنڈ امپورٹنٹ سکسیس فیکٹر واز دیٹ دے ور ٹرینڈ ٹیمز rather than individuals. That is, inspections are more successful if they are conducted in teams. یہ ایک established بات ہے کہ inspections کو individuals بھی conduct کر سکتے ہیں but they are not as successful as teams which were trained for conducting inspections. اسی طرح جن کمپنیز نے نئی innovations کو avoid کیا ہے اور جو پروون میتھڈالوجی ہے اس کو فالو کیا ہے جو کہ لٹریچر میں پبلشڈ ہے وہ زیادہ سکسیسفل رہی ہیں. اسی طرح ایک بہت امپورٹنٹ فیکٹر ہے اور وہ کسی بھی نئی ایکٹیویٹی کے لیے امپورٹنٹ ہوتا ہے وہ یہ کہ آپ پراپر ٹائم دیں اس ایکٹیویٹی کو سکسیسفل کرنے کے لیے. تو گیونگ پراپر ٹائم فار انسپیکشنز ٹو ٹیک روٹ in the organization is a very important success factor that has been reported in the literature. اسی طرح if you analyze and use data that results from conducting inspections is also a very important success factor because it convinces the management and it convinces the technical staff that yes, these are useful things, these are useful activities for defect removal, as well as they had other benefits. Some of them I'd mentioned at the very beginning of this lecture, and some we will discuss today. Another very important success factor was that the companies and the teams that were involved in the process of conducting software inspections built on their own successes. یہ اگین دس از اے کامن پریکٹس کہ جب آپ کسی چیز میں کامیاب ہوتے ہیں تو آپ اس کو مزید بہتر کرنا چاہتے ہیں. سو یو بلڈ ہاؤس ون brick at a time, you lay bricks one on top of each other. یہی حال انسپیکشنس کا ہے. جب بھی آپ انسپیکشنس سے بہتر ریزلٹس آپ کو ملتے ہیں تو یو ٹرائی ٹو پرفارم دیم ایون بیٹر ایکٹیویٹی ان دا نیکسٹ ایٹریشن. اسی طرح جب آپ یہ ایکٹیویٹی کر رہے ہوتے ہیں تو آپ ये भी सीखते हैं कि क्या चीज़ें हमने इंस्पेक्ट नहीं करनी। मसलन बहुत सिंपल जो मसलन अगर हम कोडिंग की बात करते हैं तो बहुत सिंपल फंक्शंस, बहुत सिंपल प्रोसीजर्स को, जिनको हम आम टेक्निकल लैंग्वेज में गेटर्स और सेटर्स कहते हैं, बाज़ दफ़ा उनको इंस्पेक्ट करने की ज़रूरत नहीं होती। तो ये भी आपको एक्सपीरियंस के साथ पता चलेगा कि क्या चीज़ जो है वो इंस्पेक्ट करनी चाहिए और क्या चीज़ जो है वो इंस्पेक्ट नहीं करनी चाहिए। एंड दिस is also a very important success factor in conducting software inspections. What other companies have found that if they reward successful inspections, then that also encourages inspection teams and individuals in the organization to perform inspections. There can be recognition awards, there can be announcements in the company-wide mailing list that this organization within the company has successfully applied software inspections and removed a lot of defects before they were sent to testing. And so we have seen published data in the last lecture that if inspections are conducted properly, they are very effective compared to if testing was used alone. Also, organizations, as I was saying, if they share their success stories and data with other organizations in the company, or if they publish their results in peer-reviewed journals or conferences, that also motivates other teams within the organization or as a community to use software inspections. Also, a very important thing that we started off with was that the companies allocated time, but they also allocated money and budget for conducting software inspections. So these were some of the success factors that, if you carefully think about them, are very important success factors for all the activities that are introduced in any software engineering life cycle. So whenever you are trying to introduce new activities, these are the things that you have to look for, and these are the areas that the management has to pay special attention to. An inspection is most successful when all team members treat it, that is an inspection, as a cooperative effort, not as something that is used against each other, and they try to remove defects as early as possible in the development activity. So this is a cooperative and collaborative effort, not a contradictory effort. Inspectors with good domain knowledge of the material are able to use inspections to the advantage of the company. That is, they can detect defects a lot quicker than those inspectors who do not have domain knowledge. So if domain experts are available to conduct software inspections, then those personnel should be used, because they have better understanding of the domain, and they can find defects within that work product in less time. And the third very important factor is the inspectors have to be trained in the inspection process. That is, if you want to succeed in conducting inspections, you have to treat inspections as a cooperative effort among the team members. You have to increase the domain knowledge of the inspectors, and you have to provide training in the inspection process to all the inspectors so they don't waste time. Obviously, this is going to take some investment up front, but the long-term benefits are much higher. That is, the rate of return on investment in inspections is very good. These are the situations where you want to have maximum benefits of conducting inspections. However, inspections succeed even if the conditions are not optimal. Effectiveness may not be as good as we would have liked to, but still software inspections are a very useful mechanism for defect removal. One thing that must be remembered is that the inspection data must not be used to evaluate the performance or the capability of the work product producer. That is the person or persons who have produced that work product. They must not be penalized if any defects are found. And as we have talked about this fact many times in this course, that no matter how good engineer is, how good a software designer is, how good a programmer is, there are bound to be defects in the work product that they produce. And so all levels of management must accept this value, practice it, and communicate to all the personnel within the company, within the organization, that inspection data must not and cannot be used to penalize the producers or the authors of the work product. The inspection, that is the process, uses a checklist to prepare the inspection and to verify the work product against historical, repetitive, and critical defect types within the domain of the subject. You know that every application domain has its own internal characteristics about defect types, about the kinds of defects that can occur in that application domain. So if a domain expert prepares a checklist that the inspectors have to look for these kinds of defects when they are going through the material that is to be inspected, they will then be able to find those defects a lot quicker than if no such checklist was prepared. The inspection is used to look at and to sort of approve the suitability of that work product, suitability in terms that further development can be done using that work product. So either the results can be declared as passing or as failing, that is, this particular work product is capable enough, is suitable enough that further development can be done on the basis of this work product. That is one of the main reasons of conducting software inspections. If the work product fails, then it has to be re-inspected after performing the work that was identified in the inspection process. What kind of work products can be inspected? Actually, all kinds of work products can be inspected. These include requirement specifications, design specifications or design models, software code or programs, user documentation. There are different kinds of plans that include project plan, risk management plans, software quality assurance plans, software configuration management plans. Similarly, all kinds of test cases and test data can be inspected. So effectively what we are saying is that all kinds of documents can be inspected. But this again depends on the kind of application, kind of project we are following, the domain, the expertise level of the personnel, the training that has been provided, and the time allowed. And so there are a number of factors that play into this. Let's now briefly talk about the inspection steps. The first step is overview. It provides the inspection participants a background and understanding, when warranted, of the scheduled inspection material. So it sort of gives you a background of what will be inspected. This may not be necessary if the inspectors are well aware of the application domain and the technology that's being used for inspection. Then the next step is preparation, a very important step. It allows time for the inspection participants to sufficiently prepare for the inspection meeting and list potential defects. This is the activity, this is the step which enables the individual inspectors to go through the material on their own and to try to find defects. They will be able to find and identify lots of defects, minor as well as major, if they carefully go through the material. They must carefully go through the material, otherwise the inspection meeting will not be successful. The third step is inspection meeting. In this meeting or in this step, the group collectively identifies defects before work product is passed into the next project stage. So this is what I was talking about, that the work product is either classified as passing or as failing. So this sort of is that meeting or is that inspection meeting that allows us to continue our work in the next stages. The fourth inspection step is rework. In this, the identified personnel fixes the defects which have been identified during preparation as well as during the inspection meeting and resolves any open issues that are noted during the inspection process so far. The final step is the follow-up. It verifies that all defects and open issues have been adequately fixed, resolved, and closed out. So once you are out of the follow-up, means that this work product can be used for further development. And if we are performing this inspection, let's say at the end of design, the coding can begin, or if you're doing it at the end of requirements, the design can begin. There are some other inspection steps which were not part of the original inspection process, but they have been very helpful and useful in improving the inspection process since they have been reported in the literature. The first one is planning and scheduling. To ensure adequate time and resources are allocated for inspections and to establish schedules in the project for work products to be inspected, to designate the inspection team, and to ensure that the entry criteria are satisfied, we have to have this planning and scheduling activity. So in this activity, we plan for the inspection process, we schedule different steps in the inspection process. The second important step is data recording. It is used to record data about the defects and the conduct of the inspection, on how the inspection is performed. Another very important inspection step, and that is analysis meeting, which is held after the inspection meeting to begin defect prevention activities. And then there is prevention meeting. In this meeting, we try to find the causes for selected defect types and instances or patterns of defects that occur in work products. These meetings are held on a periodic basis, maybe once a month, maybe once in 2 months, depending on the available time. So these are a very useful set of meetings that allow us into preventing, into defect prevention mode, and that is very important. Defect prevention, as we have discussed earlier in the course, is very difficult but very important part of defect elimination strategy as part of the software quality assurance activities. We'll talk about the inspection process in detail in a later lecture. This was just an introduction to get you started on what are the activities that are performed. Let's now discuss a modeling technique which can be used to model inspections and inspection process. And when we model the inspection. And when we discuss the inspection process in detail, we will use this modeling technique. This technique is known as entry task validation or verification and exit, or in short it's known as ETVX technique, which is used to capture any activity, which can be used to capture any activity. The model that is developed as part of when this technique is applied is expressed as a set of interconnected activities, each of which has 4 sets of attributes. The first is entry, we'll say E, and then there's task, which is T, and verification or validation. They're used synonymously with respect to ETVX as represented by V, and then we have exit, which is represented by X. So that's why we call it ETVX. The entry section defines the entry criteria that must be satisfied for the process to be initiated and lists the work products that must be available as inputs to the process. So any process or any activity that is modeled with ETVX technique, the entry criteria has to be met. So anything that is stated in the entry criteria has to be met before that activity or process can start. Then you have tasks, or the task section defines work to be carried out. That is the responsibility of that process. The order of the task is generally but not strictly sequential. There can be some iterations, but mostly this is sequential. Some tasks may be concurrent with other tasks, so technique also allows us to do that. Then you have verification or validation. This section defines the steps for verification that the process has been properly executed and that the associated work products meet project objectives. So this is also a very important part of the ETVX model, that once you complete an activity, you also verify that actually you have done what you were supposed to do. Then lastly, this is the exit criteria. This section defines the exit criteria that must be satisfied for the process to be terminated. The exit criteria usually define completion and verification work products in terms of qualitative aspects of the product. So these 4 criteria collectively enables us to ensure that, number one, we have the necessary preconditions that will allow us to complete an activity, that we have performed the necessary tasks, that we have met and verified that those tasks have actually been performed, and that we meet the exit criteria. Just like if you're planning to go from Lahore to Karachi, the entry criteria would be that you are in Lahore, and that you have the necessary travel arrangements, either by air or by car or by train. You have the necessary reservations in the transportation, and then you actually, if you're traveling by air, that you actually fly, get onto the aircraft, and then the aircraft actually flies and lands in Karachi, and you report, you meet somebody, you collect your baggage in Karachi. So that way you have formal entry and exit, and as well as the verification of things that you have done. So this is a very interesting and a very powerful technique that indicates the relationship and flow among the 4 aspects of an activity and between activities. The notion of formal entry, exit, and criteria to go back to the evolution of it goes back to the evolution of the waterfall model, where we had these very strict requirements analysis, and then design, and then coding. And so this maps very nicely to the waterfall model also, but this can be applied to all the iterative activities also. And this also is very nicely applicable to the inspection process. Now I will show you the ETVX process definition paradigm. You can see on the screen that the ETVX process definition paradigm, which has 4 boxes, E, T, V, and X, and you can see that the information is flowing from E to T, and then they are being concurrently performed and verified, and then once the verification is completed, they move on to the exit box. Let's now apply this model to the inspection process, and you will see the necessary conditions for performing an inspection activity. So practices and inspection process, this again is a very interesting picture. It shows that the input is a work product to be inspected, and in the entry you have a list. You're saying that there is inspection policy, there are inspection procedures, the sources, then you have training of the moderator and all the other inspectors. Then in the tasks you see the inspections are planned, perform inspections, record data on the inspection that has been conducted, record data on results. Then you have plans that are documented, and in verification and validation you have reviews with management, inspection activities measured, and in the exit you see that the criteria includes record process data, record defect data, and rework completed. And once this is done, the work product that we get is inspected and complete. So you were seeing the ETVX model for the inspection process. This picture, this diagram is a very accurate articulation of how the inspection process is performed. When we will talk about different activities in the inspection process, we will use the ETVX model, and with each process we will see and discuss the entry criteria. We'll talk about the tasks, we'll talk about the validation or verification activities, and we will talk about the exit criteria for that process. So at this time we have had a brief introduction of what steps are part of the inspection process and how we are going to study them and discuss them when the time comes, using the ETVX technique. Now let's focus our attention a little bit on the ancillary purposes or ancillary benefits of conducting inspections. I'll describe them to you now, and then we will take each one of them and talk about them in some detail. Number one is I've used 2 terminologies here: ancillary purposes and ancillary benefits. So had little discussion on benefits before. I'm going to now talk about purposes, and we will see the benefits as each of the purposes of conducting a software inspection is discussed. Number one is improvement in productivity. Second is education and increased knowledge sharing. Third is developing backup/replacement capability. That is backup or replacement capability. Very important purpose of why we would want to have inspection. Process improvement. Then we have early product quality visibility, product redeployment, and we'll see what that is. And then we have building team spirit. So let's now talk about each one of them in some detail. Productivity improvement. When the initial inspection data was reported, especially on the VTAM study, that was the first published data that is available on software inspections, Fagan reported a 23% productivity improvement in that study. That is a substantial improvement, 23%, almost quarter percent, almost 25%. That is 1/4 of 100%. And that is a very large jump or very big jump in terms of productivity improvement. An improvement in productivity is the most immediate effect of purging errors from software products, because these errors are going to bog you down into different activities and slow you down and decrease the productivity of the software development team. You find one defect and you find another defect related to that, and you try to fix those defects by testing when you're conducting testing, and then debugging. You introduce more defects as a result of the fixing process. And so this is a very ugly thing when you are one defect leads to a defect in a prior software development activity, which may lead you to another defect in an earlier software development activity. And so as a result, very naturally, the productivity will go down. But when we use inspections, and you remember we talked about chaos zone and how chaos zone was removed by using software inspections, the productivity will certainly improve. The productivity of the programmers and designers. Based on the IBM's studies, inspection reduces development cost during test by 50%. That's also a very important and substantial number. Let's now talk about education and increased knowledge sharing that results because of software inspections. And we want to have inspections to educate and increase the knowledge sharing among the participants of the software project. There are a number of activities that can be attacked with this purpose. The first is the overview meeting or the overview activity. Overview provides background on the application domain, background on the project, and background on the material that has to be inspected. So this obviously is a good training ground, a good educational activity for all those who are involved in the inspection process. Then the preparation activity itself, if an inspector carefully and sufficiently prepares himself or herself for the inspection team, he or she would have to carefully read all the material, and that is a prerequisite for an inspection meeting, by the way. But as a result of this careful preparation, he or she will gain a lot of knowledge on the work product that has been developed by someone else. The inspection meeting itself, which includes that you have prepared and that you participate in a discussion forum in trying to find the defect. So unless you understand the work product, you will not be able to find defects. Then if you have analysis meeting, that's also a very important activity in trying to educate the participants about the application domain and in increasing the knowledge sharing among among different members of an organization, of a software development team. And then we have the prevention meeting. That also is a very good mechanism for sharing knowledge and information about an application domain and how we can develop work products which do not contain defects in them. The third ancillary purpose that we talked about was backup or replacement capability. This is also a very practical objective of conducting software inspections, because many organizations have high turnover rates, and in many cases only a few people, or in some cases only one person, would really know about product or key parts of the product. So that person is very valuable to that organization's business objectives. And if that person decides to leave the company, then sometimes the project can be irreparably damaged. So wherever there is high turnover, knowledge can literally walk out of the door. And to counter that, an organization or a company should should conduct an inspection process so that others can also become knowledgeable about that work product. And as a result, many companies choose to inspect 100% of their work products. In most circumstances, this would be a very difficult decision and a very costly decision to inspect everything. And so what happens is that these inspections provide a mechanism to back up that knowledge, and we can call this as dynamic backup, which means that we are making backup, or we are creating a replacement capability for people who may leave the company or who have these key knowledge about key parts of the work product, and if they decide to leave the company. In these situations, inspections are used to spread the knowledge about the work product as fast as possible and as far as possible. And so because we have a team of inspectors and they have gone through the material to understand themselves, as well as the overview has been provided and the inspection meeting has been provided. This education also provides a flexibility to react quickly if there are customer needs. And so because there are a number of people who become experts or near experts in work products that is developed by only one person. In some situation, maintenance of the work product is transferred to new teams or new organizations within a large software company, and to become and to train the new organization and to train the new personnel, holding inspections is a very good idea. It educates the new team on a very quick timeline, and this enables the new team to discuss the work product with the author or the producer of that work product. So inspections are used to create backups or replacement owners for work products in case the original producers or authors decide to leave the company or are not available on the project because they have been assigned to do something else. And that also is a day-to-day challenge that companies have to face in managing the human resources that a company has. You have to remember that human resources are the most valuable and most important part of all the resources a company has. And to assign one individual or a group of individuals to one project as compared to another project can make or break a company. The choice for when to consider these types of inspections is determined by defect backlogs, change request backlogs, possibilities for re-engineering, risk mitigation for volatile product sections, turnover rates, recruitment rates. So there are a number of things that affect the holding of these sorts of inspections. These mostly are not held for defect removal, but they are held to train and to create backup owners and replacement owners of different work products. As I've alluded to earlier, not said so in clear words, but to be successful for these inspections, the author of the work product has to be present, because that person is the only person who can really educate or inform or share the knowledge about the work product. Inspections broaden the knowledge base of the project in the group. It creates potential backup programmers for each module and better inform the testers of the functions that they are going to test. So holding inspections just for this purpose is also a very important ancillary purpose of software inspections. The next is process improvement. Data is gathered during the inspection and later analyzed to understand the process of doing the inspection and to improve it. You see, as I had said earlier in the lecture, that we have to improve the way we do our activities. Inspection is no exception. Whenever we achieve expertise or a certain level of confidence in performing software inspections, we look at the data. We look at how many defects have been found, what has worked for us, what has not worked for us, and then try to improve on how that process can be improved. Process improvement is a very important ancillary purpose of conducting software inspections. We will talk about process improvement as a quality assurance mechanism later in the course, and so I don't want to go into too much detail here, but process improvement and quality assurance go hand in hand, and inspections conducted for the purpose of process improvement are have a very important benefit in improving the inspection process as well as the improvement of doing things in different software engineering activities. Software inspections also allow us to take a look at the product quality early in the life cycle, because if we are conducting inspections in different activities, we will be able to determine the rate of defect injection. That is, how many defects are being injected into the work product, and with the use of software inspections we can how many of them have been removed, and we can get a pretty good idea of the quality of the end product, but we will be able to do that in a much earlier phases than we know at the end. And so with that objective, we can alter the course of our software engineering activities to improve the quality of a software product, which is the actual goal of having all these formal activities and actually developing a high quality software product that meets customer requirements and that has other attributes which we have talked about in the very first lecture. And so the business objective is to develop a high quality software. And if we can have an early visibility about the quality of the software, then we can be satisfied that our software production, software development activities are going as planned. In some cases, the quality of software product is not good, or when you have multiple releases, then in some of the releases there are changes in high volumes, and it becomes a little bit difficult to manage all these changes. And some products have high defect rates, and they may have to be developed from start or developed new. And inspections can help us focus on those work products and in those areas. These are known as error-prone modules, in which lots of errors are found, and so it is sometimes better to redevelop them rather than to fix defects in those modules. And software inspections help us in identifying those modules, and inspections are a very good mechanism for highlighting and prioritizing candidate areas for enhancement. And so if you hold software inspections just to look at the areas for redevelopment or enhancement, then that is also a very important objective of conducting software inspections. The team spirit is boosted or enhanced by conducting software inspections. That is, if they are conducted properly. The review process also promotes team building. It becomes one of the first steps towards establishing a good development team by substituting an environment where programmers work alone throughout their careers for a programming team environment in which each individual feels free to discuss and critique everyone else's programs or work products. But to do that in a friendly manner and to do that in a professional manner, implicit in the concept of the team is the notion of working closely together, reading each other's work. We have to, when we're working in teams, we have to share responsibilities, we have to know each other personally, we have to know the technical strengths of each of the team member. We have to realize that the benefits and the rewards and the penalties are all shared. And so that makes a team. And that's what is important in software development. Just like any sports team, if we have the synchronization, if we have the spirit that is part of any winning team, both on the personal as well as on the technical side, that's what we want to create, software development teams. And software inspections help us in doing that. Software inspections can be incorporated in all kinds of software development processes, whether they are waterfall or they are spiral or they are iterative or incremental. Typically what we would do is that before we start a new activity, that is, whenever we have a transition from analysis to design, from design to code, we would want to have inspection and use that as a checkpoint or a milestone to perform further development. And we have a confidence building mechanism also that yes, we can make further developments using the current work product. Like any other activity in life, like any other activity in software engineering, inspections have a cost. The cost is determined by many factors. Like capability of software engineers in performing the activity, the defined process for the activity, stability of the input, and the management commitment. Inspections have a cost. Time spent on inspections should not be taken as waste of money or waste of time. If you inspect your product now, you are actually investing your money and time now, and then you will reap the benefits down the line. Concern should only be when you are conducting inspections for the first time, because there are so many unknowns at that time. Once the cost question is removed from the management's thinking, the time needed upfront in the project is no longer a concern, because the management would then allow you to proceed with inspections. They would have seen the benefits of conducting inspections and investing in inspections. Now, before we leave, I would like to show you the cost in hours per defect during code inspections. On the left, you have companies. On the right, you have hours per defect. And this is published data. AT&T has 0.67 to 1.4 hours per defect. ICL has 1.2 to 1.6. And so the numbers are listed. You have JPL, you have Bell Northern, you have HP, you have Bull, and then last you have ITT Industries. You can see that the cost in hours per defect during code inspections are another reason why you should use inspections, why all the organizations in software business should use inspections. Today we have had a good discussion on different aspects of software inspections. We will continue this discussion in the next lecture. I have given you enough evidence, I've given you more evidence on the usefulness of inspections. We have talked about the process of inspection. We have talked about what are the other reasons we should hold software inspections. We will continue our discussion on software inspections in the next lecture. Bye-bye.